Namaskar दोस्तों, welcome my dear friends. So in this video today we are going to complete our remaining questions of exercise 4, that is some important terms. So without wasting time, let's get started. So sixth question says that a ship displacing 14,000 ton is 160 meter long and 20 meter wide at the water line. If it is floating in salt water at a 6.1 meter draft, find its block coefficient. Okay, we are not going to make our calculations very complicated. We will use the formula of each and everything to find our answers. And the formula of block coefficient is CB is the short form of block coefficient. And its formula is underwater volume is divided by length into breadth into draft. So we know the length is 160, breadth is 20 and our draft is 6.1 meter. Now we have to find the underwater volume. To find underwater volume, what we have to do is we have to divide the displacement, that is 14,000 ton, with the salt water density. So when we divide it, 14,000 ton divided by 1.025, the answer is 13,658.5. 13,658.5 meter cube. Now when we solve this equation, the CB is 0.7. We have to find CB, underwater volume divided by length into breadth into draft. So underwater volume we have find by dividing the displacement with the density of the salt water. So we got 13,658.5. Now we need length, breadth and draft. Length, breadth is given and draft is 6.1. It is also given. So when you multiply these values and divide the whole answer and divide this answer by the values coming, your answer CB is 0.7. And CB is unitless. It doesn't have any unit. So next question says that, question 7, a box-shaped vessel 18 meter into 5 meter into 2 meter floats in salt water at 1.4 meter draft. Calculate the reserve buoyancy percentage. Okay. Now, to find the reserve buoyancy percentage, we need to use the formula again. Not this formula, there is a different formula for that. And to find reserve buoyancy percentage, what we have to do is, we have to divide the reserve buoyancy volume by total volume. To find the reserve buoyancy percentage, we have to divide the reserve buoyancy volume with the total volume. Now, total volume is 18 into 5 into 2. 18 into 5 into 2, that is around 180 meter cube. And we need to find underwater volume also, and that is 18 into 5 into 1.4. 18 into 5 into 1.4, which is equals to 126 meter cube. We have to find reserve buoyancy percentage. Reserve buoyancy percentage formula says that divide the reserve buoyancy volume with the total volume. Now to find total volume, these dimensions are given and we know the formula of volume is length, breadth and height. This is the total volume, that is 180 meter cube. Now we have to find the underwater volume also, that is 18 into 5 into 1.4. This is draft. This is full draft. This is 1.4 meter draft. Now after solving this, 126 meter cube is coming. This is total volume and this is underwater volume. When we will minus the underwater volume from the total volume, we got our reserve buoyancy. Reserve buoyancy volume is equals to 180 minus 126, that is 54 meter cube. Now we got our reserve buoyancy volume and total volume. Just divide it and you will get your reserve buoyancy percentage. Now to find the percentage also, you have to multiply your answer with 100. So reserve buoyancy is 54 and it is 180 multiplied by 100. 10, 10, 18, 9, 10, 5. So it is almost 30%. Yes, it is almost 30%. Reserve buoyancy percentage is 30%. Okay. Next question says that a box-shaped vessel displacing 2000 ton is 50 meter into 10 meter to 7 meter. Find the reserve buoyancy percentage in fresh water. Okay. Next question is also a very easy question. Very similar to this one. Again we have to find the RV percentage and formula is reserve buoyancy volume divided by total volume. Now total volume is 50 into 10 into 7. 50 into 10 into 7. That is almost 507. 3500 meter cube. Our underwater volume is, now guys, draft is not given but the displacement is given with the freshwater density. So to find the underwater volume, here we are not going to use the draft. We are going to divide this 2000 ton with the freshwater density. So our underwater volume is also 2000 ton, because when you divide the displacement with the freshwater density to find the underwater volume, the underwater volume comes out to be 2000 ton meter cube itself. Now we have total volume, underwater volume. We need reserve buoyancy volume, that is around 1500 meter cube. Now to find reserve buoyancy percentage, what we have to do is we will divide this 1500 by 3500, which is almost about 42.86%, and multiply by 100. This is 42.86%. Okay, next question says that a ship's saltwater TPC is 30. Find its TPC in freshwater and in dock water of relative density 1.018. Okay. We have a ship in salt water whose TPC is 30 and we have to find TPC in fresh water in dock water of relative density 1.018. Okay. whenever we have to convert the TPCs from one water to the another water, we will use the formula, and that formula is TPC of Y water is equals to the TPC of X water divided by density of X water and multiply by density of Y water. Now understand this ninth question. We can use this formula in this question. First of all, we have to consider the TPC of X, and TPC X is equals to TPC of salt water. These X and Y are the waters. TPC X is equals to TPC salt water, which is equals to 30, and that is given. Now, so density X is density of salt water, that is 1.025. Now we have to convert the TPC of fresh water. So TPC Y stands for TPC fresh water, which is we have to find with this formula. So what we will do, we just put the values directly into the formula. TPCY is TPC of fresh water according to the question, and TPCX is TPC of salt water, that is 30. Density X means density of salt water, that is 1.025, and multiply by density of Y means TPCY, TPC fresh water. TPCY is TPC fresh water, and density Y is again the density of fresh water. This means 1. So TPC of fresh water is 29 point something 268 ton centimeter inverse. This is the TPC of fresh water. Guys, remember this formula. Guys, in this question, our X is salt water. Remember this thing. So TPC dock water is equals to the TPC X, and X is salt water, and it is given, that is 30. Density of X is 1.025, multiply by density Y, and in this condition density is given, that is density of dock water, that is 1.018, and which is equals to 29.795 ton centimeter inverse. This is TPC of dock water. Guys, remember the formula. This is very important formula to convert the TPC. Now, our last question says that a ship is afloat at 8.2 meter draft in dock water of relative density 1.010. If the TPC in salt water is 40, find how much cargo can be loaded to bring the draft in the same dock water to 8.4 meter. Okay. The question is saying that a ship is floating in a dock water of relative density 1.010 at a draft of 8.2 meters. Now we have to load or discharge the cargo, not discharge, only loading. So we have to load the cargo. How much cargo we have to load to bring the draft of ship to 8.4 meter in the dock water of the same density, and the salt water TPC is 40. So we will use the formula, and that formula is, for that formula we have to find the TPC and change in draft. Cargo to be loaded or discharged. Formula is same whether it is loading or discharging. It depends on your question. Like in this question, our ship is at 8.2 meter draft and we have to bring it to the 8.4 meter. So we have to load the cargo. But if the question says the ship is at 8.4 meter draft and we have to take it to the 8.2 meter. So the formula is same, but the discharge value will be used. So cargo to be loaded or discharged, when the TPC is given, the formula is TPC multiplied by change in draft. Now, what is change in draft? Change in draft is nothing but the difference between both the drafts in centimeter or meters. Like our draft 1 is 8.4 meter and our draft 2 is 8.2 meters, or we can say that our first draft is 8.2 and second draft is 8.4. Ship is at 8.2. We have to take the ship to the draft 2, that is 8.4 meter. Now, how much is the distance or the change is there? So it is about 8.4 minus 8.2, which is equals to, in centimeters, 20 centimeters or 0.2 meters, 20 centimeters. So we got our first value, that is change in draft. And what is change in draft? This is change in draft. So in this question, change in draft is 20 centimeter. Means we can load the cargo 20 centimeter more to sink the vessel. Our change in draft is 20 centimeter. Now we have to find the TPC also. And when we have both the terms, we will multiply them, and that is cargo to be loaded to bring the ship at 8.4 meter draft from the 8.2 meter. Now TPC of salt water is 40. Okay. TPC of salt water is 40 and our ship is in the dock water whose density is 1.010. So again we are going to use the formula, that is TPC x or TPC y is equals to TPC of x divided by density of x multiplied by density of y. So in this condition, our values is TPC y is dock water, this is salt water, and this is again salt water, and this is dock water. So our values is (40) divided by 1.025 multiplied by 1.010, and that is TPC of dock water is about 39.41 ton centimeter inverse. This is our TPC for that dock water whose density is 1.010. Now we have to find how much cargo to be loaded to bring the ship at 8.4 meters. So we have TPC, that is 39.41, and change in draft is 20. What is TPC? TPC is tons per centimeter. Means if I have 1 centimeter, if I have to sink the vessel by 1 centimeter, then how much tons of cargo do I need to sink that vessel to 1 meter draft? So we have 20 centimeter and the TPC is 39.1 for that density. Means I need 39.41 tons to sink the vessel by 1 centimeter in that density of water. So I have 39.41 as TPC and I have 20 centimeter. So when I multiply this TPC with the change in draft, my answer is 788.3 tons. This is the answer. Okay guys, so this is all for today. We will meet in the next video. Till then, bye bye. Jai Hind, Jai Bharat, Vande Mataram.